Howdy, y'all. Mr. Kazi here, coming to you from beautiful Atascocita, Texas. And today we're going to talk about the mole. And what's important about the mole is that you learn what it can do. You need to understand the mole because it's a big part of what we do in stoichiometry and much of the advanced chemistry. So you need to learn the mole. You're going to need a periodic table. And you're going to need a calculator for today's lesson. Here are some assumptions I'm going to make. One, that you're familiar with the periodic table, that you know how to use a calculator, that you can perform unit conversions, and you're familiar with atomic masses. So, why the mole? Well, the mole was constructed so that scientists, or chemists in particular, would have a way to count atoms, ions, and molecules without having to count them individually. They could do it by using mass. They could weigh out certain amounts, and by using the mole, they would know how much they had or how many they had. And it's because atoms and molecules are really small, so we can't count them individually. So we came up with a mole. Now, if you want to know what the mole is really all about, go watch one of my lessons about Avogadro's number and the mole. But right here, I don't want to go through the history. I just want you to understand what a mole is and how to use it. So, what's a mole? A mole is an Avogadro's number of anything, and Avogadro's number is 6.022 times 10 to the 23. That's an important number, and that's what a mole is. And a mole is just a number. Like a dozen is 12, or a pair is 2. A mole is 6.022 times 10 to the 23, which is a humongous number. But that's because atoms are so small. Let's move on. What is molar mass? Well, molar mass is an element, or a mole of an element, is the numeric equivalent of the atomic mass, but in grams. So the molar mass is the atomic mass in grams. A molar mass is the mass of 6.022 times 10 to the 23 particles, no matter what the particle is. Bigger particles, more grams. Smaller particles, fewer grams. So, hydrogen is 1.01 atomic mass units. 1 mole of hydrogen is 1.01 grams. Or carbon is 12.01 atomic mass units. And 1 mole of carbon is 12.01 grams. The mole of an element is the numeric equivalent of the atomic mass in grams. What about the molar mass of a compound? Well, if elements make up compounds, then all we have to do is add up the atomic masses of the different elements in the compound, and it's the numeric equivalent of that in grams. Water is 18.02 atomic mass units. Therefore, 1 mole of water would be 18.02 grams. Carbon dioxide equals 44.01 atomic mass units. Therefore, 1 mole of carbon dioxide is 44.01 grams. All right, let's look at some conversions. It's not important for you to understand the history as much as it is that you understand how a mole is used. And 1 mole is 6.02 times 10 to the 23 particles, and 6.022 times 10 to the 23 particles is 1 mole. And particles can be atoms, it can be ions, it can be molecules, it can be formula units. But these conversions are used to go from moles to particles or particles to moles. Let's do an example. How many atoms are in 1.5 moles of gold? Well, I'll take 1.5 moles, multiply it by the conversion of 6.022 times 10 to the 23 atoms per mole. I know that I've got it set up right because moles cancel out. I'm going to plug and chug into my calculator, and I get 9.03 times 10 to the 23 atoms of gold in 1.50 moles. Now, in this conversion, we have moles per grams or grams per moles. And we use this conversion to go between the macro world and the micro world, and the subatomic world. And so moles per grams, very important conversion. So let's look at an example. I'll go to my periodic table and let's pick oxygen. And oxygen is 16.00 grams. And therefore, 1 mole or 16.00 grams of oxygen is 1 mole oxygen. And 1 mole of oxygen is 16.00 grams of oxygen. And with that knowledge that we can get from the periodic table, we can use to convert from molecules to moles to grams, or grams to moles to molecules. Here's an example. How many moles are in 29.58 grams of carbon? Well, 29.58 grams. I know that I want to take the grams, I want to change it to moles, therefore I'm going to use molar mass. Go to my periodic table, and there's carbon, which is going to be 12.01 per mole. And I've got it set up so that my grams cancel out. Put it in and plug and chug, and I get 2.463 moles of carbon. Let's look at another example. How many atoms in 5.21 grams of sulfur? There's my grams. Now I want to change to atoms, so I'm going to have to go to moles and then particles. There's no direct way from grams to particles, but I can go from grams to moles to particles. So I'll go to my periodic table, get my molar mass, and sulfur is 32.07 grams. I know I have it set up right because grams cancel out. And then I'm going to take and multiply by the number of atoms in 1 mole. Remember, mole is just a number, so it doesn't matter what I have, as long as I remember that a mole is 6.022 times 10 to the 23 atoms. And moles sulfur cancels out, and I'm going to plug and chug, and I get 9.78 times 10 to the 22 atoms sulfur. And that's a huge number. All right, let's recap. A mole is just a number, like a dozen, which is 12. A mole equals 6.022 times 10 to the 23 of anything. And molar mass is the numeric equivalent of the atomic mass in grams. And the reason that's possible, you can find out in one of my other videos. So, check out yourchemcoach.com and subscribe to my YouTube. Happy ions, everyone.